Good morning, everyone. Welcome to our probability and statistics class. I'm Elaine Liao and I'll be your professor for today. So, in chapter 1, we'll be discussing random variables and probability distribution. We have four lessons. For lesson number 1, we need to explore random variables and what are the objectives of this. First is to illustrate a random variable. Second is to classify random variables as discrete or continuous. Lastly, to find the possible values of a random variable. For this lesson, we'll be encountering the word sample space. What is sample space? These are the set of possible outcomes of an experiment. First sample we have is getting the number of defective cell phones in 3 cell phones that are tested at random. So we have two possible outcomes. What are they? It's the non-defective and defective. So we're going to do a tree diagram. What is a tree diagram? It has a branch for every possible outcome for each event. So our first phone, we have non-defective and defective. Second phone, non-defective, defective. Let's do it again. And then the third phone, okay, that will give us a sample space of n and n, 3 non-defective, 2 non-defective, 1 defective, and dn, and dd, defective, non-defective, defective, non-defective, defective, dd, dd, eh, ddn, and ddd. So we have 8 possible outcomes. Now we know the meaning of sample space and how to get the possible outcomes of an experiment. Let's try to find out what is random variable. It is a function that associates a real number to each element in the sample space. It is a variable whose values are determined by chance. To understand it better, let's try to have examples. In our previous example of defective cell phones, we have 8 possible outcomes. So we want to find out the number of defective cell phones that occur. And to each outcome in the sample space, we shall assign a value. These are 0, 1, 2, 3. If there is no defective cell phone, we assign the number 0. Okay, let's put it here. So 0, 1, 2, 3. So this one, no defective, defective. If there's one defective cell phone, we assign number 1. So 1 defective, defective, 1 defective. If there's 2 defective, we noted 2 defective. If there is 3 defective, we're going to note it 3 defective. The number of defective cell phones is a random variable. So the possible values of these random variables are 0, 1, 2, and 3. So in this outcome, we have 0 non-defective. Second outcome, we have 1, we have 1, we have 1, 2, 2, 2, and lastly, 3. We now know how to determine the value of a random variable. So we have two types of it. The first one is discrete and the second one is continuous. For the discrete random variables, the set of possible outcomes are countable. Mostly it represents count data such as the number of defective chairs produced in a factory. Example number 1 and what you did. Example number 2 are discrete random variables. For the continuous random variables, if it takes on values on a continuous scale, meaning on an interval, often it represents measured data such as height, weights, and temperatures. So in this example, we're going to determine if it is discrete or continuous. The first one, the number of defective computers produced by a manufacturer. This is an example of discrete because obviously this is countable. Second, the weight of newborns each year in a hospital. This is an example of continuous data because this one represents a measured data. Letter C, the number of siblings in a family of a region. This is a discrete. Letter D, the amount of paint utilized in a building project. This is continuous random variable. Lastly, the number of dropout in a school district for a period of years. This is an example of discrete. We're now on our lesson number 2, that is constructing probability distribution. The objectives for this lesson is first illustrate a probability distribution for a discrete random variable and its properties. Second, compute probabilities corresponding to a given random variable. Lastly, construct the probability mass function of a discrete random variable and corresponding histogram. We're going to encounter the word probability of an event. It is the likelihood of that event occurring. Probability is a value between and including 0 and 1. So this is the formula of our probability of event. So number of outcomes continued in the event E over the total number of outcomes in the sample space. Okay, to understand this better, let's have an example. So number 1, we have getting an even number in a single roll of dice. So in a single roll of dice, we have number 2, 4, and 6. And we have the total number of outcomes in the sample space is we have 6. So we have 3 outcomes contained in the event. So 3. Lowest term of 3 over 2, that is 1 over 2. So therefore, the probability of even numbers in a single roll of a die is of even number in a single roll of a die is 1 over 2. Okay, example number 2. We have getting a sum of 6 when 2 dice are rolled. So, P, sum of 6. Basically, you're going to copy all the statement given. So, we have 6 ways in one roll of dice. Since we have 2 rows, 2 dice are rolled. So we have 36. And what are the sample space of sum of 6? So we have 1 plus 5, 5 plus 1, 2 plus 4, 4 plus 2, and 3 plus 3. So we have 5 possible outcomes. So therefore, getting a sum of 6 when 2 dice are rolled, the probability of that is 5 over 36. Now you answer getting an ace when a card is drawn from a deck. Let's proceed in knowing and computing the discrete probability distribution, or known as probability mass function. It consists of the values of a random variable can assume and the corresponding probabilities of the values. Let's keep in mind the properties of it. First, the probability of each value of the random variable must be between or equal to 0 and 1. In symbol, we write it as, so this one. So 0 is less than or greater than probability of random variable x, which is less than or greater than 1. Second, the sum of probabilities of a the sum of the probabilities of all values of the random variable must be equal to 1. So in symbol, we write it as summation of the probability of random variable x equal to 1. So example number 1, suppose 3 coins are tossed. Let y be the random variable representing the number of tails that occur. Find the probability of each of the values of the random variable y. So first step is determine the sample space. Let h represent head and t represent tail. So we already did that at the beginning of our lesson. So what are they? Okay. H T T H H T H T H T H H and H H H. And then count the number of tails in each outcome in the sample space and assign this number to this outcome. Okay, so we have 3 tails, 2 tails, we have 2 tails, 2 tails, again, one, 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 and then 0. So there are 4 possible values of the random variable y representing the number of tails. These are 0, 1, 2, and 3. So step number 3, we're going to assign probability values, probability of random variable y to each value of random variable. There are 8 possible outcomes. Okay, and no tail occurs once. So the probability that we shall assign to the random variable 0 is 1 over 8. So for this one, 1 over 8. Okay, there are 8 possible outcomes and one tail occur 3 times. Okay, so the probability that we shall assign to the random variable 1 is 3 over 8. Next, there are 8 possible outcomes and 2 tails occur 3 times. So the probability that we shall assign to uh, the random variable 2 is 3 over 8. Lastly, again, there are 8 possible outcomes and 3 tails occur once. So the probability that we shall assign to the random variable 3 is 1 over 8. So therefore, number of tails probability 0, 1 over 8, 3 over 8, 2, 3 over 8, and 3, 1 over 8. So this will be the probability distribution or the probability mass function of discrete random variable y. In our lesson number 3, we're going to compute the mean of a discrete probability distribution. Our objectives for this lesson is first illustrate and calculate the mean of a discrete random variable. Second, it's to interpret the mean of a discrete random variable. Lastly, solve problems involving mean of probability distributions. We're going to encounter the word mean. What is mean? It is the average of the numbers. Second, the summation. So it is the sum of the terms that follow a pattern. So this is the formula in computing the mean of probability distribution that is equal to random variable 1 times probability of a random variable x sub 1 plus random variable x sub 2 times probability of random variable x sub 2 plus random variable x sub 3 times probability of random variable x sub 3. So on and so forth. Or in short, it is the summation of random variable x times the probability of random variable x. So x sub 1, x sub 2, x sub 3, and x sub n are the values of a random variable x, and the probability of random variable x sub 1, x sub 2, x sub 3, and x sub n are the corresponding probabilities. To understand it better, let's have an example. So example number 1, considering rolling a die. What is the average number of spots that would appear? So step number 1, we're going to construct the probability distribution for the random variable x, representing the number of spots that would appear. Second step, we're going to multiply the value of the random variable x by the corresponding probability. Lastly, add the results obtained in step number 2. Okay, so first, we're going to construct the probability distribution for the random variable x, representing the number of spots that would appear. So that will be 1, 2, 3, 4, 5, 6. Why 6? Because we have 6 numbers of spots. So, in random variable number 1, the probability of random variable number 1 is 1 over 6 because we have 6 outcomes. Number 2, so probability of 2 spots, so we have 1 over 6 as well. Another one for the third, it's 1 over 6 as well. So 1 over 6, 1. That will be 1 over 6 because every spot is unique from each other. So, step number 2, we're going to multiply the value of the random variable x by the corresponding probability. So, that will be 1 times 1 over 6. That will give us an answer of 1 over 6. So, 2 times 1 over 6. So, we have 2 over 6, lowest term. 2 over 6. We don't need to convert it to lowest term for now. Okay, so because we're still looking for the sum of um all possible outcomes. So that will be 3 over 6, 4, 4 over 6, and then 5 times 1 over 6, 5 over 6, 6, 6 over 6. So step number 3, we're going to add the results obtained in step number 2. So how do we represent it? This way. So summation of random variable x, probability of x. So 1, 6 plus 2, 6, 3, 6 plus 4 over 6 plus 5 over 6, 6 over 6. So 3, 6, 10. That would be 21, or 3, 3.5. The results we obtain is what we call the mean of the random variable x, or the mean of the probability distribution of x. What does this mean? This mean tell us the average number of spots that would appear in a roll of die. So the average number of spots that would appear is 3.5, or 21 over 6. Although the die will never show a number, which is 3.5, this implies that rolling the die many times, the theoretical mean would be 3.5. Okay, now let's try question number 2. We're now on our last lesson for this chapter, that is computing the variance of a discrete probability distribution. Our objectives for this lesson is first illustrate and calculate the variance of a discrete random variable. Second is to interpret the variance of a discrete random variable and solve problems involving variance of a probability distribution. We're going to encounter the word variance and standard deviation. What is variance? It is the average of the squared differences from the mean. And standard deviation is a measure of how spread out numbers are. These are the steps in finding the variance and standard deviation. First, find the mean of a probability distribution. Second, subtract the mean from each value of the random variable x. Third, square the results obtained in step number 2. Fourth, multiply the results obtained in step number 3 by the corresponding probability. Lastly, get the sum of the results obtained in step number 4. To understand it better, I know you're getting confused. We're going to answer this example number 1. The number of cars sold per day at the local car dealership, along with its corresponding probabilities, is shown in the succeeding table. Compute the variance and the standard deviation of the probability distribution by following the given step. So these are random variable x, and these are our probability of random variable x. So first one, we're going to find the mean of a probability distribution using this formula. So mean summation of x times probability of random variable x. We're going to compute it later. But first, let's solve this one. For 0, that will give us 0, 1, 2 over 10. That will give us an answer of 2 over 10. 2 times 3 over 10, it's 6 over 10. 3 times 2 over 10, that is 6 over 10. Lastly, 4 times 2 over 10 is equal to 8 over 10. Now we have this formula. We're going to add all of this. Okay? So 0 plus 2 over 10 plus um, 6 over 10 plus 6 over 10 plus 8 over 10. That will give us an answer of 22 over 10 or 2.2. So step number 2, we're going to subtract the mean from each value of the random variable x. So our mean is 2.2, right? So and then our random variable for this is 0 minus 2.2. That will give us an answer of negative 2.2. Next, 1 minus 2.2, that is negative 1.2. 2 minus 2.2, it's 0, negative 0.2. 3 minus 2.2, that is equal to 0.8. Lastly, 4 minus 2.2, that is equal to 1.8. Next step, square the results obtained in step 2. So, negative 2.2 raised to 2, that is 4.84. Negative 1.2 raised to 2, that is equal to 1.44. Negative 0.2, that is equal to 0.04. 0.8 raised to 2 equals to 0.64. Lastly, 1.8 raised to 2, that is equal to 3.24. I hope you understand this process. Okay, then step number 4. Let's multiply the results obtained in step number 3 by the corresponding probability. So 4.84 times 1 over 10, that will give us an answer of 0.44. 0.44 times 2 over 10, that is equal to 0.288. 0.04 times 6 over 10, that is equal to 0.012. 0.64 times 6 over 10, that is equal to 0.128. Last, 3.24 times 2 over 10, that is equal to 6.648. So step number 5, get the sum of the results obtained in step number 4. The result is the value of the variance. So here's the formula for our variance. Summation of the mean times probability of x. Okay, so summation. So 0.484 plus 0.288 plus 0.012 plus 0.128 plus 0.648, the answer would be 1.56. So getting the square root, last step, we're going to get the square root of the variance to get the standard deviation. So the variance of the probability distribution, this one, this is the variance of the probability distribution. And to get the standard deviation, we're going to square the variance. So how are we going to do that? So square root of 1.56. That will give us an answer of 1.25. So this will be our standard deviation. Okay, let's try answering question number 2. The variance of a discrete probability distribution is given by the formula squared sigma is equal to summation of the square of random variable x minus the mu or the mean times the probability of a random variable x, while the standard deviation is basically the square root of your variance, where x is the value of a random variable, p of x is the probability of a random variable, and mu is the mean of the probability distribution. There is an alternative procedure in finding the variance and standard deviation of a probability distribution. Let's try to have this example to understand it better. First step, we're going to find the mean of the probability distribution using the formula of the mean. So remember we got it um, 2.2, right? Okay, so 0, 2 over 10, 6 over 10, 6 over 10, 2 over 10. So number 2, we're going to multiply the square of a value of random variable x by its corresponding probability. So meaning 0 raised to 2 times 1 over 10. That will give us a 0. 1 raised 1 squared times 2 over 10. That will give us 2 over 10. And then 2 raised to 2 times 3 over 10. That is 12 over 10. 3 squared, 2 over 10. 18 over 10. Lastly, 4 squared times 2 over 10. 32 over 10. So we're going to get the mean of this one. So mean, again, the formula for it. So we're just going to add all of this. So 0, 2 over 10 plus 12 over 10 plus 18 over 10 plus 32 over 10. That will give us an answer of 64 over 10, which is equal to 6.4. So step number 4, subtract the square of the mean from the result obtained in step number 3 to get the variance. So the formula for the variance of a probability distribution, so variance summation, there you go, minus our mean. So this is the result. So 6.4 minus our mean for the random variable of x multiplied by the probability of random variable x, that is 2.2, then squared. So computing all, that will give us a variance of 1.56. And to get the standard deviation, this will be your variance. And to get the standard deviation, we're going to square the variance. So 1.56 squared. The answer would be 1.25. This will be our standard deviation, which is the same answer that we get on the first step that we did. Congratulations, class! You are now able to understand and compute random variables and probability distribution. According to Walter Baggio, life is a school of probability. Thank you for listening. I hope you've learned a lot. Let me know if you have questions and see you on our next class. Bye!